Activity 9. Applications of quadratic relations. This activity is part of Unit 4, Applications of Quadratic Relations. A quadratic relation can be used to model many different situations, such as the height of an object when it is thrown in the air, the profit returned from increasing prices, enclosing the largest possible area, the construction of containers, and much more. In many instances, the quadratic equations are used to determine maximum or minimum values. So for example, a company would be interested in maximizing their profit, whereas a farmer would like to know what is the maximum area that could be fenced in with the amount of fencing available. Recall, a parabola that opens up is said to have a minimum value at the vertex. Here's one that is opening up. It has a minimum value. The parabola that opens down is said to have a maximum value at the vertex. In our examples, the minimum value is here at y equals -4. So when x is equal to -3. In this one, the maximum value is y equals 9, when x is equal to 3. The direction of opening determines if the quadratic relation will have a maximum or minimum value. This example, y equals x squared minus 5, will have a minimum value because it's open upwards. This one, a negative sign, is opening downwards, so it would have a maximum. This one is also opening downwards, so it too will have a maximum. This one, which is a bit tricky, is also opening downwards and will have a maximum. To determine the exact maximum or minimum value and where it occurs, the vertex must be known. Therefore, the quadratic relation must be placed in vertex form. Y equals a times x minus h squared plus k. There are other ways to determine the vertex, but we won't discuss them in this activity. Here's an example. We'll determine the maximum or minimum value for the quadratic relation. Here's the parabola. The parabola opens up, therefore it will have a minimum value. It's located here. The minimum value is -7 when x is equal to 1. This parabola opens down, therefore will have a maximum value. The maximum value is located here. The maximum value is 2 when x is equal to -4. Let's look at a second example. We'll determine the maximum or minimum value of the quadratic relations. Y equals -3 times x plus 2 squared minus 1. The vertex here is -2, -1. Because our k is -1 and our h is -2. The parabola opens down because of this negative on the a value. Therefore, it will have a maximum value. The maximum value is -1 when x is -2. This is the coordinates of the vertex. Let's look at a third example. A flare is fired from a flare gun with initial speed of 100 meters per second. The height, h, in meters after t seconds is modeled by h equals 100 times t minus 5t squared plus 1. We'll determine the maximum height obtained by the flare. The relation has a maximum value since the parabola is facing down. This is our a value here because it's attached to the t squared. And it's negative, so we know it's facing down. Here it is rearranged in standard form. A t squared plus b t plus 1. Let's now take a common factor of negative 5 out of the first two terms. This is what we are left with. Then we complete the square. 20 divided by 2 is 10. 10 times itself is 100. So we're going to add 100 and then subtract 100. So negative 5 times t squared minus 20t plus 100. Here's our trinomial. We've removed the negative 100. That's multiplied by negative 5. And we add 1. H is equal to negative 5 times the factor of this trinomial, which is t minus 10 squared, plus 500 plus 1. So here we are in our vertex form. The flare reaches a maximum height of 501 meters. This is the y value of our vertex. And it hits that vertex at 10 seconds. If the flare stayed on the same path, how long would it stay in the air? When the flare gun hits the ground, the height, h, is 0 meters. Here's the ground, and we can calculate the zeros. T is equal to 0, and t is equal to what? So, when 0 is our h, it's equal to negative 5t squared plus 100t plus 1. We need to figure out what our t is. So how long will it stay in the air before it hits the ground again? To do so, we will use the quadratic formula. Take a moment now and simplify this quadratic formula.